Are you going to retake the test? Okay. Okay, so you decide. I'm going to, if you're not going to retake the test, then you can work on that video link for today. It's in Google Classroom. If you are, I'm going to do a little review. Okay. All right, so here we go. Factor out the greatest common factor. Reviewees. So I guess it's you three, right? Okay. If you're a review person, why don't you go ahead and click them close so I can remember who it is, and you guys can be engaged here. What's the greatest common factor? What's the number part of it? 3. What's the variable part? There you go. Okay, so if I take out a 3x squared, what's going to be left behind? What's going to be left from if I'm just dividing each of those 3 terms by the GCF to see what's left, right? Okay, so what's first one going to be? Everybody agree? X squared, because 3x squared times x squared is 3x to the 4th, right? How about the next one? Negative 3x. Good. And the last one? There you go, plus 11. Awesome. You got it. Good. Good stuff. Okay. I know what that was. Okay. So we're good with that. How about this one? Factor this as a difference of squares. Okay, so how am I going to have to rewrite this thing to look like a difference of squares, first of all, right? So I've got to take this expression and I've got to rewrite it as a squared minus b squared, right? Well, what's my a? What do I have to square to get that first term? 4x. There you go. Good. So that's going to be a 4x. And the second one would be what? 5. Okay. So then what's the pattern that goes with that? There you go. Boom. That's our pattern, right? A plus b times a minus b. Either order, doesn't matter. Doesn't matter which one you put first. Okay, give me thumbs. We good? Okay. All right. Factor completely. Okay, so what do we always do first when we're factoring? Say it again. Okay, good. Always try to factor out a GCF first. What would that be here? 5. I can take out a 5. Good. So I end up with 5 times what's left behind? C squared minus, what is that? 16, I guess. Okay, am I done? No, because that's, here I got a difference of squares, don't I? Right? C squared minus, yeah, but what would that be squared? That's just what squared? 4, okay. So then this is going to break up into what? You tell me. Good. 5 times C plus 4 times C minus 4. Now, don't forget to include that 5, right? Because remember, when you're factoring something, the way you can kind of do a quick self-check on this is say, okay, now what if I reversed it? What if I undid all my work? If I were to multiply all this stuff out, I've got to get what I started with. So I need that 5, don't I? Right? Okay, thumbs. Okay, question. If you just go into Math Excel, and then if you go to results, you should be able to see it should have all your scores there. Yeah. Okay, what about this one? How am I going to approach factoring this one? Just talk to me about how you do this. Like, what are you thinking as you do this problem? Magic numbers, right? And this is an easy one, or an easy trinomial or hard trinomial? It's an easy kind, right? Because a is equal to 1. The coefficient of x squared is 1. So either it's going to work or it's not, right? If it's going to work, we know it's going to fit that template. Now, what would my magic numbers, do they exist, and what would they be? Say it again. 2 and negative 10. Good. That's it. Now, how would you check this? Because this is a super easy one. I mean, all these really you can check on a test. How would I check that one? Well, I mean, I can't really plug it. What would I do? I mean, how could I know if I got that right? Okay, good. I mean, you could check, you could do a double check on the magic numbers, but factoring is just the opposite of multiplying, right? I could just undo it and I could FOIL all this stuff out, and I should get that when I FOIL it out, right? If you want to check it, that's an easy way to do it. Okay, I think we're good with it. You guys got that so quickly. Let's try one of the harder ones. Let's try. It's only one of these on the test, but I'm going to make you do one of them. So here's a different, harder trinomial to factor, right? This time, I always want to see if I can factor out a GCF, but I cannot. So I'm stuck with A being 25. So this is a slip and slide problem. Okay, so let's, whoops, hang on one sec here. Got to answer a question. Okay. Okay, let's see. Okay, so what are the steps of slip and slide here? Okay, so there's step one, right? Step one, we're going to do slip and slide. Step one, we're going to slip the 25 over and multiply by the -8. So that's going to give me x squared plus 10x minus 200. Brooklyn, what's step two of slip and slide? Good. We're going to factor the basic trinomial. Okay, and this is the step where we know if it's going to work, by the way. If we can find magic numbers, it's guaranteed to work. If we cannot find magic numbers, we give up because factoring is not going to work. Okay? Okay, so what are magic numbers here that multiply to -200 and add to 10? There you go. Good. 20 and -10. Now those can be tricky to find. I mean, you might have to make a table and just list all the factors of -200 until you get them. Okay, Caleb, what's next? Good. Okay, and we're dividing the magic numbers by 25, right? Good. So whatever we slipped, which is just A, right? Whatever we slipped in step one, we're going to divide each of our magic numbers by that. Okay, what's next? Mr. Avery, what's next? Okay, good. Reduce those fractions, and that's going to give us x plus what? We can divide each of those by 5, get 4/5. Good. And Brooklyn, what's the last step? Slip and slide. Okay, so the last step is just if I have denominators, I slide them up in front of the x's, make them coefficients. Okay, so we got it then. That's our answer. We end up with that 5x minus 2 times 5x plus 4. And the order of the factors makes no difference. Okay? So how we doing? Brooklyn, is that all those, are you good with those steps? Yeah. Okay. All right, so obviously it's not prime, is it? Okay, so this is easiest problem on the test. This one should take about 1.32 seconds, I'm going to say about. Maybe 1.33, I'm not sure. It's one of those two. It's a quick one. What are the answers? No? -7 and 2, how come? Okay, can you guys tell me, see if you can pretend you're explaining this to somebody who doesn't really understand algebra yet. There you go. So we're using the zero product property, aren't we? Right? We know that I've got a product of factors. The only way that a product can equal 0 is if I multiply by 0. So either x plus 7 has to be 0 or x minus 2 has to equal 0. So then I just solve those equations. X plus 7 equals 0 when x equals -7. x minus 2 equals 0 when x equals positive 2, okay? So this is a question where they've already done the work for you, essentially, right? They've already factored it. Now all you have to do is just set the factors equal to 0. Yes, sir. Yeah. Okay, so here's one step harder, right? This is one where they haven't factored it for me. So now I've got to set this thing up. I've got to factor it. So what are the steps to factor that? What am I going to do first here? Okay, bring the x over and set it equal to 0. Good. Okay, so I got to push everything over to the left side so I can put it into standard form, right? So it's set equal to 0, okay? So first step then, we'd end up with x squared minus 4x minus 21 equals 0, right? Now what? We would, if there were one, we'd find one. Yeah. There's not this time, though. So now what? Magic numbers. Good. Okay, so Brooklyn, what are my magic numbers going to be here? There you go. So what are my solutions then? There you go. Very good. Okay, how about this one? What are we going to do here? No, there is. Just think about the steps. There you go. Always want to factor out a GCF. And I'll tell you what, if you've got, this one looks simpler than the previous one in a way, doesn't it? Because this one ends up having 3 terms. We get a trinomial. Trinomials, at this point, we just have to factor. We don't have another option, right? We have to factor. Later on, we're going to get one more option. That's the last thing we'll do this year. But for now, we have to factor. I've only got 2 terms here, right? I'm not going to have to do some fancy magic number thing here. The only thing I can do in this case is try to factor out a GCF, and the only other possibility would be a difference of squares, which isn't going to apply here, is it? Right? So all we can do is factor out our GCF. So we take away a 7x, and what's that leave us with, Caleb? If I factor out a 7x, what's left behind? X plus 2, good. Okay, so what are my solutions then? I've got 2 factors here. I've got 7x times x plus 2. What's the solution I get from that factor? 0. Yep, good. 7 times what equals 0? 0. So I get x equals 0, or what's my other one? Negative 2. There you go. Okay. Thumbs? Good. All right. Okay, let's simplify this. So now I've got 8 times the square root of 20. When people miss this, what they had trouble with was dealing with that 8, right? Think of it this way, though. This is already just a product of 2 numbers. It's 8 times the square root of 20. So it's going to be 8 times whatever we get when we simplify the square root of 20. We're just multiplying the 8 times whatever we end up without, whatever ends up out front. So what about that square root of 20? Let's factor it. Factors of 20. 2 and 10. Okay, we can do 2 and 10. I'm going to suggest we do, and it works. I don't mean to say that's not going to work, but I'm going to go 4 and 5 instead, just to get in the habit of doing it this way. How come I like the 4 better than the 2? Because it's a perfect square, right? It's going to immediately break into a couple. So we get a couple of 2s, single 5. So Brooklyn, what am I going to get then for my answer? For the square root of 20 part. It's okay, it's the other way around, right? Think about that. What's our saying on that one? There we go. Okay, so here's the saying. The saying is, couples go out, singles stay in. Okay, that's an easy one to remember, right? Couples go out, couples are going out on a date, singles are staying home, right? Couples go out, singles stay in. So now, again, Brooklyn, what's the square root of 20 part going to be? Okay, you got the 5 in the right place, but what goes out front? Not a 4. A 2. Because there's a couple of 2s. Okay, now let me show you why, though, because I showed you the trick, and couples go out, singles stay in as a quick and easy way to do this, but let's not lose sight of the mathematical basis for that. So what we've done is we've broken up 20 into 4 times 5. So the square root of 20 equals the square root of 2 squared times 5. You see why we're only getting a 2 now? Because when we get the square root of 2 squared, the squared and the square root cancels. That's why when you have a couple of something, whatever you have a couple of, that's the number that appears once out front, okay? So I've got 2 times the square root of 5, but what else do I need to do here, Caleb? Yeah, I got an 8 times that, right? So 8 times 2 is 16, and I get 16 radical 5, okay? All right. Okay, what about this one? Top and bottom, right? Yeah. Okay, and how come? Brooklyn, what's wrong with this to begin with? Yeah, no tens in the basement, right? So whatever the stranded square root is, I multiply top and bottom by that. Okay, so we get square root of 5 over square root of 5. On the bottom, multiplying a square root by itself just cancels the square root because that's the same thing as squaring it, right? So we're getting 5, and on the top, the square root of 11 times the square root of 5 just gives us the square root of 55. And there's no couples in that, obviously, because we know it breaks into an 11 and a 5, right? That's what the factor tree would look like. So there we go. Thumbs? Okay. Okay, solve this one. Now, there really are 2 ways we could do this, right? We could factor this by a difference of squares, but let's not, right? Let's do what I think is a little bit easier method here. I can point to a single x, so what can I do? If I can point to a single variable, I can isolate it, right? That's you guys will get tired of hearing me say that. You probably already have gotten tired of it. You probably blocked it out because you got tired of hearing it. If you can point to a single x, you can isolate it using inverse operations. So that just means opposite direction, starting at the bottom of our PEMDAS tree and working up. So Brooklyn, what's the first thing I've got to do to isolate that x? There you go, good. So first step, add 25. Okay, and that's going to give us 16x squared equals 25. What's next? Now, sometimes people here wanted to square root next, but that's not next. Inverse operations tells us that's not next. What should be next? Yeah, we got to work our way up. So next I've got multiply, divide, right? So at this point now, I'm going to divide both sides by 16 to cancel the 16s. Because when we're using inverse operations, remember, what it should kind of feel like mathematically when you're doing this. Feels like every step you're pushing stuff away from that x to get it by itself, right? Every step is getting us one step closer to getting that x isolated. So now we've got an x squared equals 25/16. Now what's the last step? There we go. Finally, the only thing left on this side that prevents that x from being by itself is the exponent, which we undo by square rooting. Okay, good. So then we end up with x equals, what do I have to include if I square root both sides of an equation? True, but before I even think about that, there's just kind of an automatic thing I always do. If I square root both sides of an equation, I got to include plus or minus, right? Every time, because I'm getting both solutions. So I'm getting my plus or minus the square root of 25/16. So what's the square root of 25/16? 5/4. We got it. Exactly. Okay, there it is. 5/4 and -5/4. Okay. All right. Okay, what about this one? What are the steps here? They're wanting us to solve the equation. I can point to a single x, so I'm square rooting both sides. Okay, I mean, I'm isolating x, right? Which in this case, I guess I kind of gave it away. I'm going to use inverse operations. What's the first thing I run into here? Does everybody see that? Yeah, I mean, I've got parentheses in this, right? And so here are my parentheses. Well, look, I don't get to parentheses until the last step. So is there any addition or subtraction to do? No, because it's all in parentheses, right? Any multiplication or division? No. First thing I hit is an exponent. So my first step is just getting rid of that guy by square rooting both sides. Okay, so Brooklyn, if I do that, square rooting both sides is going to cancel the squared, so I'm going to get a 6x minus 1. But what do if I square root both sides, first thing I do? But plus or minus, right? I got to include my plus or minus. And then I've got my square root of 5 there, okay? And I can't simplify that, right? No couples in 5. Okay, last two steps to get that x by itself. Michael, what's the last two steps? Add the 1. Where do I put the 1? So remember, when we're adding, and we've already got a plus or minus there, this is kind of my little trick. You always want to put it in front of the plus or minus, okay? So we're going to add 1 to cancel those, right? And that's going to give us 6x equals 1 plus or minus the square root of 5. Last step, divide by 6. There you go. And that's our answer, okay? I think you can probably, have you guys tried it? Can you enter it like that with the plus or minus in there? Okay, so if you can't, that's okay. Then all you have to do is just enter it once with the plus and once with comma, once with the minus, okay? We did talk about one other thing, and that is it's good to split those fractions up. So I make it 1/6 plus or minus the square root of 5/6. In this case, it's not necessary because I can't reduce either fraction, right? It's just always a good idea to do, just in the event that sometimes you can reduce one or the other, okay? But the Math Excel will accept it either way. You can have a common denominator or not, doesn't matter. You can either leave it this way or this way, okay? All right, so what do they? There you go. They just left it with a common denominator, okay? So now here are the bonus questions. These are kind of tough, right? Okay, so I mean, if we don't get through these, that's all right. These are only worth 1 point apiece. What's the GCF here? 2y to what power? The 7th, right? I can only undistribute a y to the 7th from both. So if I take a 2y to the 7th out, what am I left with from that first term? 1. Yeah, good. It's 1, isn't it? Because I'm dividing each of these. If that's my GCF, what I'm really doing is I'm dividing each of those by 2y to the 7th to see what's left behind. Well, 2y to the 7th divided by 2y to the 7th is 1, isn't it? Good. So I get a 1 plus, what's the other one going to be? If I divide 6x y to the 8th by 2y to the 7th, what am I going to get? 3xy. Good job. Okay, good. All right, let's try one like this. So what could I do here? Factor out the y. What else could I factor out? Did you say y? I said 5. Oh, 5y. There you go. Sorry. Yeah. 5y. There you go. Perfect. Okay, so we could factor out a 5y. So this is equal to 5y. And what's left behind if I factor out a 5y? 80 divided by 5 is 16, by the way. I'll give you that. Okay. Minus 1. Okay. So that's good, but can we go further? You can. You're right, Michael. What can you do? By that, you mean, what do you mean by that? Okay, good. We're going to write it as a difference of squares. Okay, how did Michael know to look for that? Well, probably, I'm guessing, you tell me if I'm wrong, but he saw that I had, first of all, I had a difference, right? If that had been a plus, there'd be no chance. But I have something minus something, so there's a chance. And then you just ask yourself, could I do it? Could I write the first thing as something squared and the second thing as something squared? And you can this time, right? So we could write this as 5y times 4x squared minus 1 squared, right? And so there, my a is 4x and my b is 1. And so that's my answer. Okay? All right, what about this one? This is tough. This is really pretty tough. I mean, it's only a 1-pointer. But anybody give me an idea how they could think about that? A couple ways we could do this, but how could you think about that? It's going to be, I mean, that's why it's a bonus. It's tricky. Yeah. Okay, so if this is going to work, right? There's no guarantee it's going to work, but if it's going to work, what would my template look like this time? I know those have to be x's, right? And I know I'm going to have a magic number times y there, aren't I? So I know I'm going to get y's there, but I'm also going to have a number with it because I get a y squared. So now we just have to find magic numbers that multiply to 15 and add to 8, 3 and 5. Right? How's that work then? Well, it works because if I FOIL it out, I get x squared. And when I multiply this term by that term, I'm getting xy's, right? I'm getting 5xy. When I multiply this guy by this guy, I'm also getting xy's. I'm getting 3xy. So that's just a tough one. You know, I mean, either if you want to kind of look back at that and think about it some more, you can probably make some connections and say, oh, okay, the light goes on. But that's a pretty, to me, that's the hardest one on the test. Okay, how about that one? This is a good problem. Now, what people want to do here sometimes, which is incorrect, is they want to say x minus 4 equals 10 or x plus 5 equals 10. But there is no 10 product factory or product property, right? There's no 10 product property. There are an infinite number of ways you could multiply two numbers and get 10, right? But there's only one way to multiply two numbers and get 0. You have to multiply by 0. So we can't do something like that. What we've got to do here, does everybody see? I would have to simplify this whole thing and put it in standard form. So I would have to FOIL out the x minus 4 times the x plus 5, okay? So if I do that, if I FOIL this out, if I distribute the x, I'm going to get x squared plus 5x. If I distribute the negative 4, I'm going to get minus 4x minus 20 equals 10, right? I can combine like terms, and that's just going to give me x squared. If I combine those two, I just get plus x minus 20 equals 10. Subtract 10 from both sides to put it equal to 0. Get it in standard form. And now it doesn't look so bad, does it? But the trick, the reason this one's a bonus is because you have to see that you have to do some work to put that into standard form to get it all equal to 0. And from there, it's pretty simple. Okay? Are we out of here in like a minute? Oh, man, how about it's pretty good timing? We got through the whole thing.